Yes? So, ready? So, whatever we have discussed in the morning, what we have discussed in the morning? Anything, nothing was discussed. It was only one side, no discussion. Okay. So I hope at least in this session you will be interacting. Right? So in this particular session we will talk about how to prepare research proposal. The art and science of preparing research proposal. Let us see next. Because we are a pharmacy student, we have to prepare some project, research proposal for pharmacy. How to start with, what to do? So first, we have to think about in which area I want to work. See, suppose you want to prepare a project for your, say, academic purpose, or suppose you want to prepare a project for any funding agency. In this presentation, I will cover the proposal for funding agency also and proposal for a student for their particular degree. So, when we want to prepare any research proposal, we have to identify what are the first areas where I want to work. If you look at the areas given here, like cancer or diabetes, cardiovascular, anything. I hope, being a postgraduate student, you are very well aware about whatever areas or whatever diseases you have put in here. Whatever severity of these diseases and how these diseases are affecting the whole community. I hope cancer, diabetes, cardiovascular, everything is known except microbial resistance. Or it is known. What is microbial resistance means what? Is it a thirst area? Is it a need presently? See, there is abuse of antibiotics. There is huge abuse of antibiotics or antimicrobials, I say. What is the meaning of abuse? Unnecessary use. Unnecessary use. See, everybody is suffering from any viral infection or throat. He used to or she used to go to medical and ask for acid. As common. No, everybody can get easily acid. And the situation now, or it is existing, maybe those who are directly working with patients and in the medical shop, they must be knowing that acid is not giving any effect. Right? People used to come again. I have taken acid for 5 days, no effect. Now then doctor gives some amoxicillin like that. What does it mean that now azithromycin means microorganisms are resistant to azithromycin. It is of no use nowadays. Earlier, when we were in schools, in that time, the brand which was working, that was Septran or Bactrim, which was containing sulfur drugs. Sulfamethasone and trimethoprim combination. Nowadays, we don't see these brands in the market. Right? Have you seen any time sulfamethasone trimethoprim combination? No, it is not working. Right? So it is, the pathogens are resistant to this. Likewise, if this thing happens with this rate, if antibiotics are becoming ineffective in near time, no new antibiotic is coming in. No new, I am saying. Whatever coming in, analogs, penicillin analogs, cephalosporin analogs. New generation is not coming in. If situation is like this, means in near future there will not be any antibiotic available to treat a simple microbial infection. So people may die because of simple microbial infection because no treatment available. This is a major, I say the microbial resistance is a major issue nowadays. All others are major, definitely, no doubt about that. But this is one more thing. And alternative medicines. What is alternative medicine means what? Other than allopathic medicine. People are searching for it. If you are able to give best option, or comfortable option, or option with minimum side effects. See, major problem with modern medicines or allopathic medicines is their side effects, which are not good. Those who have taken the remdesivir as a Sanjeevani booty, with paying high cost. How much? High cost. Right? In a single day, it was banned. Right? How come it is possible? Any Sanjeevani booty banned instantly, instant ban. Instantly it was observed that it is so toxic. Then what about those who have already taken? What happened to that? Many things are there, many issues are there. Let us not put leg on our right? So it's running. But that's why morning I said ethics, ethical practice. Those who have some ethics, avoid this. Okay, forget about that. So if anything alternative can come out with better result, then people are searching for that. This can be one of the thirst areas for the research. Next. See, now when we think about development of drug, how drug can be developed? Where from drug comes? What are the sources of drug? See, drug can come from natural source, plants, microbes, animals, or it may be by some chemical synthesis. Agree? So what is drug? What do you mean by drug? When I say drug, means what drug? Morphine, codeine, heroin? You are talking about that drug? Or what is drug? Any chemical is drug? Benzene, nitrocyanol, toluene is a drug? Then what is drug? Benzoic acid is drug? So drug is something that is found safe and efficacious and approved by regulatory authority. Then it becomes drug. Not everything is drug. So what is the source of drug? Drug may come from plants, or from microbes, or from animals, or by chemical synthesis. It may be any chemical entity. But a chemical entity, every chemical entity cannot be a drug. So what happens when you want to get something from any source, say from plant source? Suppose you want to identify a drug, or a drug-like entity. You identify drug-like entity from a plant source. In that case, what you have to do? You have to identify some plant, right? Then extract the chemical constituents from the plant, right? Then after extraction, isolate that chemical constituent. How many constituents contain any plant? Do you know? A plant can contain how many constituents? N. Don't. Multiple number of chemical entities may be there from the plant source. Okay. So after extraction, isolate individual chemical entities. Then identify that individual chemical entities, that is characterized, structural interpretation. Right? Then isolate in pure form. Then test on the animals, that is called preclinical trials. Right? If it is found safe and efficacious in animal trials, then go for clinical trials. Phase 1, phase 2, phase 3. If it approves, then FDA approves that it as a drug, enters into the market. Right? And then phase 4 trials, post-market. This is how drugs comes in market. I have given example for a chemical entity coming out of plant. The same thing for, say, coming out of microbes, coming out of animals, or coming out of chemical synthesis. Microbes are giving us. Sure? Can we get drug from a microbe? How? Do you know any drug which has came from the microorganism? Is there any drug that microorganism gives? You are brilliant points, right? Yes, all antibiotics are coming from microorganisms. Microorganisms gives drug. Sure. Likewise, any source can give chemical synthesis. Yes, most of the compounds which are synthesized chemically, then tested. So you got the all route how drug is developed. It can be from any source. Identify that. Test. If it is safe, efficacious, get approved, it becomes a drug. Right? Once it is approved, then you can formulate it in suitable formulation. Paracetamol. Paracetamol is a drug? Yes. Now, we take powder paracetamol? Then, here the formulation development comes. Right? API, active pharmaceutical ingredient identification development, it is part up to this. Okay. Paracetamol identified as a safe, efficacious as an antibiotic, approved as an antibiotic drug. Okay. Next step comes administration of that. So, what are the formulations available for paracetamol? Only tablet? Syrup? Only syrup? So, as per requirement of patient, if a small kid, he can't have solid dosage form, so liquid, syrup is available. Okay, suppose a normal person can have a solid tablet, he can swallow. Okay, if he can't swallow anything, bed injected. Right? As per requirement. So, this is what is called as formulation development. Those who are in physics, they can think of this. Does it mean that only physics can think of formulation development? No. Anybody can do anything. It is not like if this specialization will do this like this. No. If you have that skill, knowledge, everything, anybody can do anything. Agree? Okay. So, identification of drug, molecule, active pharmaceutical ingredient, and formulate it into suitable formulation. Here R&D is divided, like say basic research and formulation development. You must have heard about R&D, basic research and development, F&D, formulation development. So the difference is, a basic research means drug discovery. F&D means formulating that identified or developed drug into suitable formulation. Then one more thing, analytical research. What is analytical research? Right, analytical method development. It is also there. Whenever new things are coming, new drugs are coming, new impurities are identified, new degradants are coming in. So that for that purpose, new analytical methods development is required. So this is one more area. Have you heard about Ranitidine? What for it is used? And is it there in the market now? Some few days before, you must have heard the news. It is banned. It is banned because some carcinogen impurity is identified in that. So it is continuous development. Because ranitidine have some impurity that is carcinogenic, that's why it has been banned. So who identified that? How it was identified? What is the method for identification? Well, these are analytical methods coming in. Okay? Now, the research basically starting with first identifying drug by any source. So we can say the phyto research, phytoconstituents, chemical constituents from any natural source, synthetic chemistry, anything. Once it is identified, it is prepared, its characterization, structure elucidation, where all analytical methods comes in. Once it is identified, then it's testing, animal testing. Pharmacology research comes in. Preclinical trials, studies on animal. So how studies on animal is carried out? Do you know anything about how animal studies are designed? See, in this session actually we will have some rough idea about everything. So when we think of animal experimentation, suppose you have synthesized new compound, any new compound, and you want to test it for its any activity, say anti-diabetic activity. So how to design this, how to perform this, what is required? For that purpose, very first thing that whatever you have synthesized, that compound is required. Second thing, animal, you have to decide some model on which animal you want to test. Initially, you have to start with small animals, either mice or rat. So, the smallest animal used for testing is mice. The very first thing you have to do is, you have to first find out its toxicity. That is its LD50. Lethal dose. Minimum lethal dose, right? So how to find out lethal dose? LD50 means 50% of population when it dies. So that dose we have to calculate. Means what, suppose you have to take 6 animals, 6 mice, you give dose in rising, say 1 mg to whatever, right? And identify a dose at which 50% population dies. It means its LD50 value. This is how you have to find out its LD50 value. Then you have to find out its doses. Right? So you have to start with particular doses and identify whether it gives effect or not. Now when you are testing for anti-diabetic activity, the very first thing you have to do is, you have to induce diabetes to the mice. Anti-diabetic activity cannot be observed in the normal mice or normal rat. So for that purpose, we have to induce diabetes. So some diabetes inducer is required. What is that? It may be streptozotocin, it may be alloxin, whatever, right? So you have to induce first diabetes, make them diabetic, then treat with your compound, and then check whether it is showing anti-diabetic effect or not. Is it okay? No. Still you have need something for comparison. Some standard compound is required. So known anti-diabetic, say metformin. So you have to compare the activity of compound which you have synthesized with a standard drug which is known that it may be metformin. It means you need groups of animals, standard control, right? Then only vehicle control, then your test group. So how many animals required in one group? Statistically, to be a statistically valid? 6, right? So I think you are known with this, right? So one group of 6 animals is required, minimum. Why 6? Why not 1? To average out, validation, right? 1, it may give false result. That's why statistically valid result. Suppose you want to have a statistically valid result, you need a multiple number than single. When you go for titration itself, you used to take 3 readings and then have mean. Right? That's the reason. A single reading may be erroneous. That's why multiple reading, and to be a statistical valid, we need a multiple readings. That's why we need a multiple answers. Got it now? So by any means, when you identify new molecule, you have to isolate it, structurally characterize it, then go for its activity testing, animal testing. Now, once it is found effective and safe in animal trials, then it goes to the clinical trials. Animal trials, it is called as preclinical trials. Clinical trials means trial on human. Now, when you are going for trials on animal, it needs permission of some committee. You know this? Animal Ethics Committee. Institutional Animal Ethics Committee. So there should be a constitution, proper constitution of Institutional Animal Ethics Committee. There should be proper animal house. Then you can perform this. Otherwise, you can't perform like anything, get with some animals and test. It is not allowed. It is a crime. It is a crime. So, it is not allowed. Now, once in clinical, preclinical studies or in animal trials, when it is found safe and efficacious, you go for clinical trial in humans. Now, very interesting. Suppose you have to give a dose to first human being. How much you will give? Are you getting what I mean to say? A new compound. You have tested that compound in animals. Okay, you found it safe. You found its LD50 something X. It is efficacious. Okay, it's a rat or mice. Okay, cat. Suppose you want to give human. Imagine. So how to start with? Is it safe? एवढी गंमत आहे. कोणातरी एखाद्या जिवंत माणसाला काहीतरी द्यायचं आहे. ते माहिती नाही आपण काय कसं होईल त्याच्यात कसं काय होईल. That is dose okay, but you have to start with 10%, 1/10 of LD50 in the animal. What I told? 1/10 of LD50 in animal. That much initial dosing we have to start with when you have to give the human. So safe, very safe. Then gradually one can increase. Do you know how much time it takes in drug to develop? It may take 10, 15, 20 years. That is the reason. But you know, the vaccine were developed in years. Surprising. Better not to comment on that. Whether it was emergency or what. Okay. You see, now it's emergency to those who have received it. That is the main issue. Okay. So, I hope you are clear with this whole process. New entity, its testing, efficacy, clinical, preclinical, clinical. Then once it is approved, then you can think of its formulation. Okay, now you can prepare proper formulation, suppose tablet, capsule, whatever. Then that formulation needs to be tested also. Okay, before that tell me, suppose you have given powder and you have formulated. Suppose, how you will start? Formulation development. How will you start? Suppose you have to prepare a tablet. Forget about what you have to prepare. Suppose it has been decided that I want to make a tablet of X material. How to start? What is the first thing that is to be done? What is it? It is called the pre-formulation. Pre-formulation studies. Simple. Means what? To form a tablet, you need API. Say it's a paracetamol, you need paracetamol. Then what you need? Whatever additives. So binder, then additive, whatever. So whatever you need, A, B, C, D things, you have to first check its interaction, whether they are compatible to each other. That is called the pre-formulation stage. Once they are compatible to each other, then you can formulate, you can make A, B, C, D, D, A to Z formulas, different combinations, right? Then you will check its evaluability for all the evaluation parameters. What are evaluation parameters for tablet? Okay, everything, hardness, disintegration, dissolution, whatever. So you will evaluate for all the formula which is suitable, which is found perfect, that you will select and you will formulate it. Right? Once it is formulated, then again test it. Just testing by dissolution or disintegration, these are called the in vitro studies, out of body. It will not suffice. Right? Then you have to administer it to the say first animals, then get whether it is safe or not. If it is safe, then go for clinical trials again. clinical trials for that formula. Then if it is safe, efficacious, everything, then it will be approved as a that drug. It can come in the market, then give it to the patient and all. This is whole about a summary of, I can say, a drug development process. How a drug from research to drug to the patient. How it goes. Now here, various research components are involved. Right from basic research, analytical development, then pharmacological investigation, clinical investigation, post-marketing investigations, market research, everything needs. What is research? The finding which is existing already. Research. It is existing. We have to again find it. That's why market research. Now people say, what is market research? Market is already existing. Then what you are doing? Analyze all this situation. Collect the data. Again, in the morning I have shown the experimentation, data collection, data analysis, then interpretation, then your conclusion. Right now, this whole process is a research. Anything. So it needs every pre-experimentation, experimentation, post-experimentation, data generation, data collection, data maintenance, data analytics, and all. Conclusion. So this is the whole process that you have to do. Okay? Next. Now, just for information, if this is one example we have taken, the drug development from the plant source. So what is required for that? You need to select the plant. Why I am talking about plant, you know? Next please, one slide. Look, whatever drugs available in market, 40% of the drugs are derived from the plant source. Again, quinine, all anti-malarial drugs, artemisinin, aspirin, many, you take a name, it is coming from the plant source. Are you getting? Though they are chemical entities, they are chemical entities, simple, single chemical entities isolated from the plant. Right? That's why I am talking about this. This is the area, actually, that needs to be explored. Chemical synthesis is okay, though I am from medicinal chemistry. I like it very much. I like synthesis very much. But I also know the fact that how much outcome is coming out merely by only synthesis. There is very limited outcome coming out. So this is a natural source. A ready drug is coming. Artemisinin, you have heard of artemisinin. Artemisinin. What for it is used? It's anti-malarial. Recently, some Chinese scientists discovered it. She got a Nobel Prize for that. Right? So it is from the natural source. Likewise. So new drugs are coming like this instead of synthetic route. Or you can go for semi-synthetic route like modified natural analogs. Are you getting? Means what? Natural analogs, you structurally modify that. Simple 1-step, 2-step modification. That can be a new molecule coming up. Right? Natural molecule is formed safe. Just go for its computational studies, identify what properties to be changed, accordingly put some substitute in that, and that could be a new entity. Likewise. So, if you want to go for drug discovery from the plant source, you need selection of plant, then authentication of plant. What is authentication means? Selection of plant, okay. And then authentication means what is this? Plant is plant. Tulsi, okay, Tulsi. Everybody can know this is Tulsi. So she may say this is Tulsi, he may say this is Tulsi. Then what is authentication? Or is there any difference between this Tulsi and this Tulsi? Black Tulsi, white Tulsi, this. There are various varieties, species, genus, different species in the same family. It may be the same family, but various varieties. Right? So identify if this basis changes, then all chemical constituents are the same. So who will authenticate it? The person who is botanist. Right? He can only identify what it is. Suppose you have given a paracetamol, what you will do? A powder, and identify it. You will go for spectral characterization, check what is melting point, what is IR, NMR mass. Then you can say no, it's a paracetamol. Okay. Likewise, suppose you say it's a tulsi, then someone should authenticate it by having all tests and check, and then he will label it. No, this is this. Right? Then this is what is authentication. Again, it needs a competent person. Authentication from the competent person, not just someone says and you will. Then extraction and isolation. Extraction. You know extraction. Oxylating, solvent extraction, maceration, cold extraction. There are different methods. So from that plant source, again, when you are doing from the plant, there are various components of the plant. Root, stem, bark, leaves, whatever. So by literature or by records, you can know which is the component of that plant that is containing the required chemical constituent. You can use that particular plant, or even you can use whole plant, whatever, as per the depending upon which plant you are using. Go for extraction. Extraction, various solvents as per polarity and all that. Then separation, fractionation, identifying different constituents. Then structural elucidation, characterization. Then biological screening, whatever I told, it's like a new chemical entity. Screen for its activity, which activity it shows, and accordingly, if you want, you can go for molecular modeling studies like docking and computational data. By which mechanism it is showing a particular activity that can be seen. You can go for synthesis. A similar molecule can be synthesized, or some structural modifications can be done. Semi-synthetic analog. Likewise, penicillin. Penicillin is natural penicillin, benzyl penicillin. But amoxicillin is analog of penicillin. It is called a semi-synthetic analog of penicillin. Only one functional group is added, and it becomes the same or even better than natural penicillin. Likewise, any entity from the natural source can be structurally modified, right? And that is by synthesis, and that can be tested for. So this is how the path for drug discovery from the plant source. Same can be followed for animal source or microbial source, or a synthetic is a different issue. Next slide. So see, the plant sources, these many drugs, even what I said, 40% of drugs in the counter, they are plant origin. Okay, next. Now, okay. Many times I uttered the word drug. Okay. So what is that? Something safe and efficacious. Important. It should be safe, it should be efficacious. Now, what is the definition of safety? Do you know cancer treatment? The fellow who undergoes chemotherapy, the major side effect associated with cancer treatment is very severe. It loses hair, then weakness, every system goes like damaged like that. Suppose such a severe side effects, if they are associated with paracetamol, okay, we will take it, paracetamol. Why not? Because it is reducing your fever. Efficacious. But so serious side effects. With paracetamol, suppose you are losing your hair. Okay? See, means the safety and efficacy balance is required. The cancer, it is end is death. So to avoid death, we can lose hair. It's okay, na? It's better to alive than losing the hair. That's acceptable. So such a toxicity, such a side effect, which are acceptable, that depends upon what efficacy, what purpose it is used. That's why anti-cancers with severe side effects can be acceptable. But a paracetamol like drug or a simple treatment, so side effects should be acceptable. The severe side effects cannot be likewise. Okay. So here we are talking about a drug action. How drug shows action? The drug is now formulated, a tablet. Say imagine a diclofenac tablet. We are visualizing effect of diclofenac tablet. Imagine, suppose you have knee pain. You have a diclofenac tablet. Okay. Tablet, solved, finished. Pain is over. Okay. Does it happen like this? See, imagine you have pain. You have tablet with water, solved. It relieves your pain. होतं की नाही? असं होतं की नाही? गोळी खाल्ल्यावर थोड्या वेळ तरी पेन जातो की नाही? थोड्या वेळ लगेच नाही थोड्या वेळ. What is this? How it happens? What processes takes place after swallowing a tablet? Being a pharmacy fellow, we should be very clear with this. Otherwise, people may feel it's a magic. Have a tablet, pain gone. It's not magic. What exactly happens? Can anybody explain me till relief of pain after swallowing? एक गोळी खाल्ली, जिभेवर ठेवली, एक ग्लास पाणी पिलं, आणि अर्धा एक तासाने पेन गायब झालं. इथपर्यंतची प्रोसेस कोण सांगेल मला? काय होतं त्यामुळे? हे विद्यापीठात येत तसं नेमकं काय होतं काय होईल? चल मी परफेक्ट सांगतो सगळं इथून पुढे लक्षात ठेवा. सी टॅबलेट इज अ सॉलिड डोसेज. हाऊ टॅबलेट इज प्रिपेअर्ड? First maybe by granulation or may not be by granulation, whatever. If required, you may prepare granules. If not required, you may not prepare granules. Now, when granulation is required, when it is not required, anybody can tell. What is required? What is safe compressibility? Kadi asks safe compressibility. So flow properties matter, right? Suppose you are given a sodium chloride powder. Suppose you are asked to prepare a tablet of sodium chloride. Which method you will use? What are different methods for tablet preparation? Granulation or direct compression. Granulation means wet granulation, direct granulation. Now, when you are given a sodium chloride, whether you will go for direct compression or granulation? Direct compression, simple. It has good flow properties, no need to prepare granules. Okay, so whatever. Now you are clear with tablet preparation. Now tablet is prepared. The patient is receiving tablet. Okay. First, when it goes, stomach. What happens in the stomach? Okay. First it will disintegrate. Disintegrate means what? The tablet to granules. Then it will release drug. Now here drug is diclofenac. In the stomach it will release diclofenac. What will happen? That diclofenac it is there in the stomach now. It will be absorbed. Where? Blood. No. It is small intestine. From stomach it will be absorbed into the systemic circulation, that is in the blood. This is called as drug absorption. Suppose there is other drug. Forget now diclofenac. Now there is something else that you expect it should reach to the intestine. As it is, what do we do? How? Sustainable is different. Suppose you want to protect which protein? Enteric protein. Those drugs which are acid sensitive sensitive. Means what? If they comes in contact with acid, they will degrade. So that kind of drugs, if suppose you want to prepare oral tablet for that, tablets for that, then it needs to be protected from the acid environment. So it is coated with the enteric coating. What is enteric coating? It will not break in the acidic coating. It will be intact. After 2 hours, normally transit time is 2 hours. After 2 hours, it enters into the intestine. In intestine, what is pH? Okay, basic pH. Okay. So, in intestine, because of basic pH, enteric coat breaks up. Then granule is released. Then drug is released. Then it is absorbed. Okay, now? Okay. Now drug is absorbed in the blood. Now what happens? Drug distribution. Blood carries that drug wherever it goes. Agree? Where blood goes? Everywhere. Agree? So drug is distributed throughout the body. Get it? Throughout the body. But the brain is protected. There is a blood-brain barrier. It is a highly lipoidal membrane. So it will not allow many drugs to enter into the brain because it is highly lipophilic. Only highly lipophilic drugs can enter. Again, this is what is drug distribution. Drug is distributed throughout the body. What are you taking the diagnosis? Diagnosis again. Drug group so, though we want it here, the drug is distributed throughout the body. Throughout the body. Okay, so as like it is also received to the knee where there is pain. Why pain? There may be some damage of the tissue. So what are the markers for pain? Tissue damage, release of arachidonic acid pathway. What is prostaglandins and prostacyclins. So arachidonic acid converted to prostaglandins, prostacyclins by enzyme COX. So how diclofenac act? How it gives pain relief action analgesic effect? Because it blocks enzyme COX. Cycloxone. Okay. So what is COX enzyme? What is enzyme? Enzyme gas. Because what is enzyme? Is it acid, base, lipid, protein, carbohydrate, fat? What is chemically enzyme? These are proteins, chain of amino acids, right? So the COX is a protein, means chain of amino acids. Okay. See, right? Now the COX, which is converting arachidonic acid to the prostaglandins, prostacyclins, that's why the pain is. That is a symptom of that. Now, what that diclofenac does, it goes to the COX and it binds to the COX and stop action of COX. Is it so easy? The COX is waiting. Come, diclofenac. Come, bind with me. Right? So, when is the protein? What is the protein? Chain of amino acids. How many amino acids? And there will be 400, 300, 500 amino acids. N number. So it is a chain, like a thread or hair you can see. So imagine a hair in the water. A single hair, a long hair in the water. It is continuously changing its shape. Can you imagine? Hair in the water, dynamic. So likewise, your COX is in a dynamic state of conformation change. Now diclofenac, a small molecule, going to that COX. Now COX, because it contains 400 amino acids approximately, it may not be 4 exactly, then out of 400 amino acids, the diclofenac binds only with 4, 5 or 10 amino acids of that. Right? So where are these 10 amino acids where diclofenac has to bind? Okay? Lock है, lock. अक्खर लॉक है, आपलं उघडच आहे, ती चावी फक्त त्या कीवर मध्ये जाते. पण ते लॉक पण डायनामिक आहे, एका जागेवर स्थिर नाही. पण नॉर्मली तिथे लॉक स्थिर आहे, आपण चावी घेतो लगेच उघडतो. पण लॉक पण हलत आहे. कंटिन्युअसली चावी पण आलती कंटिन्युअसली मुव्हिंग ती कधी मॅच होणार कधी ते फिट होणार आणि कधी are getting this. Can you imagine? So this is what is happening. So that COX is also moving, changing its shape. Your drug molecule is also changing its shape. When both are complementary to each other, they will bind. Then it will stop action of that COX. Then conversion of arachidonic acid to prostaglandin cycles can be stopped, and pain will be relieved. That's why लगेच गोळी खाल्ल्या थांबत नाही. एवढा वेळ जातो अर्धा तास पाऊण तास या सगळ्या प्रोसेस आहेत. Got it now? So this is how drug shows its action. Okay, but is it possible for anybody to visualize what is happening in the body? No. That's why this plasma concentration curve is studied. Because we can correlate this with concentration of drug in the blood. No, okay. So here this is the zero time when it is swallowed. So gradually its concentration in the blood increases. When it reaches to minimum effective concentration, it starts its action. Its concentration goes on increasing. Similarly, because of its metabolism and excretion, simultaneously when drug is absorbed, simultaneously it is metabolized also, it is excreted also. So at a particular time, its concentration will start declining. Right? So its concentration will decline. After some period, after say 6 hours or 7 hours, you may feel like pain again. So again you take another tablet. Are you getting? So this is the dosing interval. The dosing depends upon the duration of action. How long it shows action? Then after you have to maintain its concentration above minimum effective concentration. That's why the dosing interval is given. And higher dose, minimum toxic concentration. Means what? If instead of having one tablet, 100 mg, suppose you take 200 mg, what will happen? Its concentration will be higher. As its concentration is more, it may start showing some side effects, toxicity. If it is still higher, then higher toxicity, like that. So the concentration should be maintained in its desired therapeutic range. So the dosing interval is decided based on this plasma concentration. Okay? Got it now? I hope right from drug to its formulation, what are the minimum steps to be considered while doing research? I hope that I have just focused, that I have summarized. Okay, next. So, drug discovery, methods of drug discovery, how drugs are discovered, various examples, various methods are given. To discover drug, one needs first hit, lead, and then drug. Hit to lead, lead to drug. This is a way of drug discovery. So, these are the various methods for lead discoveries, lead identification. Serendipity, random screening, like this. So, serendipity, what is serendipity? Means it's accidental discovery of drug. There are many drugs, those who were discovered accidentally, without any plan. One example, very known example is penicillin, that Alexander Fleming, he got Nobel Prize for that. Who was Alexander Fleming? Medicinal chemist, doctor. He was microbiologist. See, the microbiologist can develop a brilliant antibiotic like penicillin. Still it is working. So the qualification doesn't matter. When you say that I am from physics or I am from chemistry or I am from pharmacology, doesn't matter. You need a skill. See, he was microbiologist. Look, penicillin still it is required. How many lives he saved during that World War? Before that, no antibiotic was there in existence. It was the first antibiotic, which was discovered accidentally. That's why I say curiosity and patience is required. How it was discovered? You know the story of this? Anybody know the story? How many of you know the story? You know the story. Rest you don't know. So I must tell. How I know? See, he was a microbiologist. He was working on Staphylococcus aureus. What is staphylococcus? Gram-positive bacteria. So while working, then you must be knowing the petri dish, petri plates, then culture growth and like culture media. So once he decided to go on vacation for a week, he closed his lab and went for vacation. By keeping everything as it is, closed down shutter, went. A week after he came, he found that on one petri dish where he tried to grow that Staphylococcus aureus, on one plate there is some area where there is no growth of microorganisms. On the one plate, particular area has no growth. He surprised. Apan kya kila? Nahi job. He surprised. Why not? Everywhere there is growth of Staphylococcus aureus, but there is particular area where there is no growth. Okay. He tried to identify reason. Then he found that the growth, where the area where there is no growth, there is some contaminant. Some foreign material is there, and around that, the microorganism of Staphylococcus aureus has not grown. Then he tried to find what is this? What is this thing where around that there is no growth? Then he tried to find, and it was a fungus. Now again, surprise. Fungus is a microorganism. One microorganism is not allowing to grow another microorganism, though he is not human being. Normally, human being is one fungus, one microorganism is not allowing to grow another microorganism. How it is possible? Then he tried to find that fungus, what that fungus is. It was Penicillium notatum. And why it is not allowing to grow microorganisms? Because the fungus, when it is growing, it gives secondary metabolites. These secondary metabolites are again chemicals. That is benzyl penicillin. Because of that secondary metabolite from the fungus, benzyl penicillin, there is no growth around that. So penicillin was. Then he identified what is that secondary metabolite. Then he went for structural elucidation and all that. Then it was benzyl penicillin. So this is how benzyl penicillin has been identified as an antibiotic. Now the research was not stopped here only. The benzyl penicillin, that is natural penicillin or penicillin G, it is only active by injectables. It is not stable in acidic environment. It is not stable in alkaline environment. So it cannot be given by oral route. So what happened? The scientists decided to work on this and prepare some acid-stable penicillins, some alkali-stable penicillins, so ampicillin, amoxicillin, proxicillin, diproxicillin, various penicillin analogs, those who are there in the market. These are the semi-synthetic penicillin analogs. Got it? So this is what is curiosity works. Okay. So likewise, even that diazepam is anticonvulsant. It is again accidentally discovered. In the Roche, someone was working on the project. I will tell you this in short. He was working on the project. He synthesized 242 compounds and tested for activity. He found that no compound is active. So he terminated the project. 2 years later, during cleaning of laboratory, he found one vial which was not tested. So to complete formality, he submitted that vial for test and it was active. Then it was modified as a diazepam. This is again accidental discovery. Then random screening, non-random screening, metabolite studies, clinical observations. These are the various methods. Random and non-random is what? Random. Every chemical tested for each activity. If found active, okay. If not, forget. Likewise. So each and everything to be tested. It is of not use. It is very costly. Non-random is what? Suppose you have 100 compounds. Then group them on basis of their structural similarity. Right? Then suppose there are 10 compounds with same structure. Instead of testing 10, test 1. If it is active, test of 9. If it is not, forget. Likewise. So this is non-random. Metabolite studies. See, metabolism is what? Drug metabolism is what? Conversion of drug into its more polar so that it can be easily eliminated from the body. in the body is to facilitate its elimination. See, body doesn't accept anything foreign material. Anything comes foreign, it will try to eliminate it out by any mechanism. The one part is metabolic. Now you must have heard that fexofenadine. Fexofenadine? What does it? Brand Allegra. It contains fexofenadine. It is non-sedative antihistaminic. This is actually metabolite of terfenadine. Look at this. Earlier the terfenadine was used. It is non-sedative antihistaminic as anti-allergic. Then it was observed that its metabolite fexofenadine is more active than terfenadine. So now in market terfenadine is not there. Fexofenadine is there. Right? This is how the terfenadine is the clinical observation. See, Viagra was discovered by clinical observation. It was up to clinical phase 2. It was under test as a anti-anginal drug. What is anti-anginal? Angina pectoris? Chest pain because of constriction of coronary arteries. Constriction of arteries. So what is required? Vasodilator is required. So beta blocker is different, but phosphodiesterase inhibitor. This Viagra is phosphodiesterase inhibitor, right? So it gives vasodilatation. So it was under investigation for angina pectoris till phase 2. In phase 2 clinical trial, it was observed that it is effective in sex organ and not on the heart. So it is the research has been modified to its anti-impotency. Right? This is how the clinical observation can give. Now importantly, rational drug design. Rational drug design. Earlier, whatever we have seen, either it was accident or random thing. Rational means what? You know target, you know ligand, you know lock, you know key, you can develop a duplicate key, something else like that. So everything is clear, the mechanism is known. Right? So rational drug design used, where here the computers are in use. Right? It may be structure based drug design, it may be ligand based drug design, like that. So various drug design processes can be done. Detail This particularly it is going for drug design process, right? Means what? Suppose you know the target. Likewise, diclofenac. Diclofenac is ligand, and COX is a target. Now the COX. Suppose you know you want to develop a drug which can inhibit COX. Now target is identified. It's a COX. Then means lock you know. Now suppose you have a lock but you lost a key. What do you do? You can prepare duplicate key. Similarly. Right? Similarly, you can prepare different ligands and you can use computer softwares. You can test virtually. Suppose you have 1 lakh keys, virtual keys, and try which one is fitting. Instead of synthesizing, actually, virtually you can screen and then synthesize which is best. It will save your time, money, everything. This is what is the glory of this rational drug design. Or secondly, that is ligand-based drug design. Means you don't have lock, only key. You go to the key maker and then ask him to prepare duplicate. Likewise, QSAR, format to form mapping. These things are like ligand-based drug design. Ligand is known. You have to develop a new drug, new ligand. This is how the structure-based drug design or ligand-based drug design can be done in this CAT or rational drug design. Okay, next. Okay, so this development process if you look at, it starts here from target identification, function study, drug design and optimization. Target identification means what? Suppose you want to develop a drug for cancer. Okay, you must say earlier in the first slide, I talked about some thirst area, where suppose someone wants to work in the cancer. So what is first thing you have to do is, first study the cancer pathophysiology. What is cancer? Uncontrolled, unwanted growth of cells. Means cells are multiplying. Because of cell multiplication, there is a tumor formation also. In that case, you have to identify a particular step that if that step is stopped, the cell multiplication will stop. So that mitosis and all things, cell division, you know. Right? So in that case, suppose you identify a particular target, like in inflammation, what I told Cox, like in cell multiplication, cell division, there are multiple enzymes which are taking part. It may be DHFR, it may be topoisomerase, it may be polo-like kinase, it may be EGFR, lot many targets, n number of targets are there. So what you have to do is, you have to identify which target you want to hit, which target you want to act on. That is your lock. Identify that target. Then start designing your keys, your molecules, or it is called ligands, that can fit into that target. If they can fit into target, it will stop that target to do its normal function. So, the cell multiplication, cell division will be stopped. So, no unwanted growth of cells and everything. Clear? So, this is how the target identification, functional study, drug design and optimization is done. Got it? Okay. Then once lead is identified, then it needs to be optimized. Lead, what is lead? Lead means a compound, it has required biological activity, but it is not safe. It may not be safe. It may have some toxic effects. So, the structure of that lead needs to be optimized so that it will show its required effect, but it will show minimum toxicity. Okay, leave it. See, suppose this is the key, right? If this is the key, when I want to open the lock, which part of the key is required to open the lock? Only this part. This part only enters in the keyhole, it opens. So this is called a pharmacophore in case of drugs. Right? Only this part is required to show the activity. Then what the hell all this is? See another key. Only this part is required. What the hell rest of the things are required? Yeah. Why to increase the cost? Getting it? प्रत्येक जर एवढाच पार्ट आपल्याला गरजेचा आहे, स्ट्रक्चरमध्ये एवढे 2-4 जो फंक्शनल लूप गरजेचे आहे, तर आम्ही 10-20 कशाला? काय गरज आहे? आहे का नाही सांग? का Exactly. Suppose you only prepare this part, how to hold it, how to bring it to this side of action, right? This means the pharmacophore of a drug, it is a part of the structure that actually interacts with the target. But the rest of the part is required to bring it to the target. हे नसेल तर आपण लॉक पण घेऊ शकणार नाही. So bring it to the target. So rest of the part. And because of this thing which is there in addition, it may give some toxicity. So lead optimization is required. Getting it? This is how lead optimization is done. So functional genome, drug target, target validation, lead discovery, lead optimization. Once lead is optimized, go for preclinical. Preclinical means animal trials. If it is okay with animal trials, go for clinical. If it is okay with clinical, it will pass. It will be approved as a drug. It will enter into the market. That's all. It's simple. Because slide में drug आता है. But imagine time, cost, manpower. तुम्हाला माहिती आहे एवढ्या दिवसात तुला नवीन ड्रग आला आहे. तरी जरा हे झालं लेक्चर आहे. एक एक्सरसाइज करा. मागचं सगळं लिटरेचर वाचा आणि लेटेस्ट नवीन ड्रग कधी आलाय कोणाचा नवीन ड्रग नवीन फॉर्म्युलेशन किंवा एखादा अॅनालॉग पण नाही जसं ॲमॉक्स आला हे त्याला काही म्हणता येणार ना कारण ते एम्पिसिलिन, एमोक्सिलिन, हा पेनिसिलिनचे अनालॉग आहे. तो नवीन नाही. असं नवीन काहीतरी काय आलंय का जरा काढा माहिती. मॅडम सांगा, मॅडम मला सांगते मुलांनी ह्या शोध लावलंय, हे नवीन काहीतरी आलंय, आता माहिती घेतली. ओके, आपण बघूया काय येतं, कधी येतं, कसं येतं, आणि मग आपल्याला काय करायचं, आपल्याला काय काम. ओके, चलो नेक्स्ट. ओ चला, इज इट विजिबल? ओके, लेट इट सी.
वाइट कलर.
Substrate breaking. That's it. You must have seen one reel here in time. Okay. So this is my project. I would like to explain which we have worked on. Fortunately, ICMR offered 47 lakhs to us for this project. So that's why I would like to share with you how to design a project, how to work on this project. So it will give some money. Research असंच नाही होत. Research नाही करायचं. काहीतरी पैसा लागतो. Someone sponsor is required. Who will give money? And why someone will give money to you? का द्यावा? का पैसा द्यावा? घोडे रेसॉर्स. तिकडे जातो आपण रेस खेळतात. आपण मी ते कुठल्या घोड्यावर पैसे लागतात? आता जे जातात तिकडे रेस खेळायला ते काय ते बघत असतील ना घोड्याकडे. कासच घोड्याकडे एखादं लग्न आहे, ज्याला ते वाटतं की हा जिंकू शकेल, विनिंग हाऊस. अरबी घोडा चांगला असतो. आपल्याला जर काही कोणी पैसे द्यायला असं वाटत असतं रिसर्च तर आपल्याला तो विनिंग हॉर्स सारखा आपला प्रोजेक्ट, आपलं प्रोफाईल कसं असेल तर देते. सो लेट अस सी दिस. दिस इज ड्रग डेव्हलपमेंट, antic acid drug development. This project is where we have targeted enzyme polo-like kinase 1. Okay. Now why polo-like kinase 1? Before that, next slide. See, why polo-like kinase 1? What is cancer? You know, cell multiplication, mitosis process. Now look at this process of cell multiplication, M phase, multiplication phase, and look at how many times the PLK1 appears. 1, 2, 3, 3 circles you can see. These are the 3 places where there is a role of PLK1. It means what? The PLK1 is required for cell multiplication at more than 1 steps. Okay. Now suppose if we are able to stop the action of PLK1, the cancer multiplication will be stopped at 3 stages. It will be more effective. Inhibiting 1 step, it is better to inhibit at 2 or 3 than 1. Of course, synergistic effect. That's why we have identified the PLK1 as our target previously. Okay. So what is this PLK1? The PLK is a family. Out of that, 1, 2, 3, 4, 5 different PLKs are there. Out of that, we have selected PLK1. Again, like plants, we are saying this is tulsi, this is tulsi, this is tulsi. Very different varieties. So you have to select particular. So PLK is a family. Out of that, you have to identify a particular one. So we have taken PLK1. What it is? It contains 603 amino acids. Look its molecular weight, its heaviness, its structure. Okay. Now, so how many amino acids are there? Existing. अमाइनो एसिड्स किती असतात? 30
52
किती 20 असतात? मी कन्फ्यूज केलं मला 20 वाटतं माहिती नाही काय MCQs मध्ये प्रॉब्लेम ABCD दिलं की म्हणतात त्यावेळेस वाटेल पण 603 तर नसतील. Sure, 603 amino acids, no, 20 amino acids are there. So this particular PLK1 contains 603 amino acids. Okay. Now, once this target is identified, what we have to do is we have to get this target structure. How to get the structure of this target? Where it is available? It is available on protein data bank. Protein data bank is there, a known site, RCSB site is there, where the structures of proteins are available. Those structures who have been already elucidated, these protein structures are available. Suppose someone identify a totally new protein, new target, then you have to go for its IR, NMR, 3D NMR, then X-ray crystallography, every studies, and then you have to establish its structure, chemical structure. If totally new target is identified. But normally at this stage, we work on the available protein data bank. So this is PLK1, it's available on the protein data bank. So you can get that structure from protein data bank. This is computational data. So in the software you can import that structure of PLK1 which contains 603 amino acids. Okay. Now this structure is known. Now we have lock. Now out of this protein structure you have to identify what is its binding site. The lock is one key hole identifier. Right? So out of that 603 amino acids, which 5, 6 or 10 amino acids, those who are involved in binding with the ligand, that is needs to be identified. Okay, this is called as identification of binding site. Okay, once binding site is identified, you have to design a library of compounds. Library of compounds, because we have to do a virtual screening. Virtual screening means you don't have to synthesize all. The computer is doing simulation. Okay, so you can design a library maybe of 10 compounds, 100, 10,000, 1 lakh, or whatever. So you can design that virtual library and go for docking studies, where you will find that which is best fit in that. Then accordingly you can shortlist and go for synthesis. This is all the overall project is. Next. Okay. Please. Now I hope those who want to work in this particular area, they have understood how to plan your research in this area. Identify your disease in which you want to work. Then study the pathophysiology of that disease properly. Identify target. Then identify ligand if available from literature. Then design a virtual library. Go for virtual screening of multiple compounds. Shortlist selective compounds for synthesis. Synthesize it. Structural elucidation of that compound. Biological activity and further. This is how the steps can be done in this. Okay, next. See, this is actually, if suppose anybody wants to apply for funds, those who are providing research grants, the list is given. It may not be right now useful for you. Next. Some international agencies are also there. They also can provide grants for research projects. So, okay. So, selection of project. When you want to select project, it should be novel. Novel means what? Novel. Nobody has done earlier. So you have to check its novelty first. Anywhere there are sources, various sources are available, databases are available. From that databases, you have to confirm first that whatever you are going to do, it is novel. Your project should be on current issues. Whatever latest, when COVID was there, everybody focused on COVID. Like that. When current issue, you have to focus on current issue. Then practical feasibility, of course. Just thinking of no use. It should be practically implementable. Useful to society. That is important. Again, cost effective. Suppose you are giving something, but if it is not affordable, no use. So cost effectiveness is required. Commercially viable. Commercially viable means what? जेवढा खर्च घातला तेवढा तरी यायला पाहिजे किंवा प्रॉफिट काही मिळालं पाहिजे. समजा ऍटलीस्ट तेवढं ब्रेक इव्हन असलं तरी ठीक आहे. कमीत कमी लॉस मध्ये जरी म्हणजे घर घालून काय म्हणतो तसं नाही चालत. घर घालून डेव्हलपमेंट आपण असं नाही करत. काही वर्ष मी केलं तर आपण क्रिएटिंग एम्प्लॉयमेंट means what? Suppose you are doing some project, it should create some employment to the others. Right? So, suppose you set up some manufacturing, or suppose you identify or develop some drug and manufacture it. You are giving employment to many manufacturers, sellers, everything. That is again great. Okay, next. Now, okay, one more example. That drug resistance we were talking about, that I would like to share with you. See, I earlier told about sulfonamides. Sulfonamides because they are not in use. Sulfonamides, they are competitive inhibitors of PABA. Right? And so the folic acid synthesis and folic biosynthesis, that process is affected. Now, where this is a compound which we have developed, they are acting on the same pathway, but at different sites. The tannin binding pocket, you can see this. Two pockets are there, PABA binding and tannin binding. A lock with two keywords. So we targeted another tannin binding pocket, so that the same pathway can be inhibited. Got it? So these are the different molecules. Means this is novelty, you can say. So known thing. DHPs inhibitors, sulfonamide class of drugs, they are so known. But what novelty we found is the different target is different. Okay, next. Okay, sorry. Next. So, when you have to prepare any research proposal, what should be the component? Title, objectives, introduction, background literature survey, methodology, time frame, and the availability and budget. Okay, next. Title should be unique, punchline. Look, the example is given. The title can be written like this. See, synthesis and molecular modeling studies of trial derivatives as polo-like can be inhibitors as anti-cancer agent against breast cancer. So, this is one type of title. Read the second title, which is promising. Second, targeting PLK to design, right? So this is how target should be some specific and like a punchline. Next. Once target title is set, you have to set its objective. Objective means what? आपल्याला काय करायचं? हे करायचं, कशासाठी करायचं? Okay, you have to set objective. Next. Introduction. What is there in the introduction? It shows a need of that work. का करायचं? That should be clear in this introduction part. That is called a need of research. The need of research should be clear. Okay, next. When need is clear, you look at the background. Means literature survey. Anti-cancer करायचं आहे, PLK inhibitor करायचं आहे. Okay. मला ते करायचं आहे. पण आधीपर्यंत काय केलंय, त्याचे बॅकग्राऊंड काय आहे, मागे 10 वर्ष, 15 वर्ष, 20 वर्षात काय काम झालंय, ते सगळं बघणं म्हणजे त्याची लिटरेचर सर्वे बॅकग्राऊंड. गेटिंग. काही कुठलाही आपण करायचं ठरवलं तर आपण काय आधी आपल्याला कुठल्या गावात जायचं असेल नवीन ठिकाणी तरी आपण कोण जाऊन आलं, कसं गेला, कुठला रूट होता, काय वापरलं, बस गेला, ट्रेन गेली, फ्लाईट गेलं, काय दॅट इज बॅकग्राऊंड. Okay, so this is background. Okay, next. Methodology. Now you have decided what you have to do. So how to do it? Experimentation part, method. By which method you are doing? That methodology has to be set. Okay. So when you are designing methodology, see that each and every claim which you make, that should be experimentally supported. Accordingly, you have to set a methodology. Next. Of course, time structure, how much time is required. Every project came from, say, 2 years duration, PME, maybe 3-4 years duration. Any project, suppose any funding agency is giving a project, it has some duration, 2 years project, 3 year project. So timeline is everywhere. So you have to follow the time frame and you have to set first. This is for this purpose, this many days, this purpose, this many days, like that. The time frame needs to be framed. Next. Then you have to check where you are working, where you want to perform this, what are the facilities available. Right? So whether these facilities are sufficient to satisfy your aim or your objectives, or to achieve your objectives. Likewise. So the facilities, if they are not available, you have to create them. Or you can ask for that facilities. Those if there is someone sponsoring. Next. Okay, this is for particularly for the project funding. Suppose you need principal investigator, co-investigator, some supporting staff. These salaries can be covered in this. Right? Suppose those who are funding any projects, they funds for everything. They funds for small things purchase to manpower. Everything they provide, everything, but you have to give budget. Right? Okay, next. Yeah, budget. Budget is, see, how much is required for staff. Suppose you need 2 or 3 staff. The salary of staff for say 3 years, that you have to calculate. Non-recurring. Non-recurring is what? Equipments. Any fixed asset. Suppose you are going to purchase equipments. That is non-recurring. Recurring means chemicals, glassware, that can be. Then travel. Suppose you need any travel. Contingency, emergency, suppose anything is required. And any more HR. So accordingly you have to frame budget. You have to ask for money. And if they are agreeing, if they found it is good or something outcome based, they may provide you funds. Okay, next. Now, see, suppose you do some research. Suppose you do some research and you want that it's your intellectual property and you want to protect it. So what to do? You suppose you want to put some last 2 slides. Suppose you want to protect your property. Then what to do? People do research. One thing what they used to do is they publish it or present it somewhere. Publish it means what? You can submit to a journal. Early morning, what I was talking like journals, elsewhere, Springer, Willis, these are the publishers. They publish different journals like Journal of Medicinal Chemistry, Biological Medicinal Chemistry, different journals. So they used to publish these journals, scientific journals. What you can do? You can submit your manuscript as per their format to that publisher. They review it with experts. Suppose they find it is suitable but needs some corrections, needs some revision to be done. They communicate it that these are the revisions you have to make and resubmit. Then if it is found suitable and as per their guidelines, they will accept it and they will publish in their journal. Okay, research you have done and published, finished. Then people will refer it. It will be a guideline for new researchers. What someone has done, what he has done. Like literature survey you will appear. He has done this, he has done this. So it will give some directions. But it will not remain your own intellectual property. That is what is happening with publication. Getting it? So it is a public, or say it may Hello. It may be a public property, or that it may be a right of that publisher, because you are giving copyright to that agreement we used to give them. So the whole right, the author is giving whole right to publisher. So apply. But if you want to protect your research, if you want to protect your property, intellectual property on your own, you can go for patent. But patent, suppose you do something, first you have to check whether it is novel or not. Novelty check. Okay, I have, you can go for patent. If it is not novel, forget it. Then if it is novel, yes, you draft patent. It may be provisional patent or complete patent, whatever. You file that patent. Then after some period, it will be published into the patent gazette. Then you can apply for examination of that patent, so that the patent office will appoint some examiners. They will examine your patent, whether it is really novel, whether it is really of something else. Whatever claims you have given in the patent, whether these are valid claims. If it is so, then they will grant it. Or otherwise, before granting, if they found some queries, examiners find that there are some issues or if they have some doubts, they will raise that queries. So you can reply to that queries. If they satisfy, then they grant it. Now the patent is granted. Now you are the owner. But it is for 20 years. But you have to maintain it. Again, you have to pay some maintenance charges. So both for 20 years you have to maintain it. So this is all about Indian patent. But even if you feel that your research needs to be protected across the globe, so you can go for world patent or US patent like that. So accordingly, your intellectual property can be protected by patents. Okay. So publication and patent. This is a major difference between. Okay. Next. So suppose you go for patent, likewise these are the different benefits after patent. It gives a monopoly, right? Then royalty you may receive, like royalty, global recognition, goodwill, many things. Still, nobody will call honorable. Nobody will call. Suppose you want to be honorable, you fill your form in the next. Don't fill them that patent file. Go for that there. Okay. Thank you. I hope you listen.
Now raise some questions. No questions? Or else you can take the mail ID of sir in the...
See my mail ID, mobile number is anywhere. Right? You are the first slide also. You share the sentence and anybody can call any time. No issue.
If you have any project related or any other type of doubts, sir is willing to share his insights. And you can contact sir through mail communication or through mobile communication.
You can ask in Marathi also.
Right now, if you are willing to ask any questions, you can ask. Don't have any doubts right now. Later also you can ask.
तुम्ही म्हणजे कॉलेजमध्ये येऊन पण भेटू शकता. तुम्हाला वाटलं तर तुम्ही टीचरच्या माध्यमातून काय विचारायचं तरी विचारू शकता. तुम्हाला स्वतः पर्सनल काय असतं तरी
don't have any, let us not have any hypothetical barriers. Hypothetical barriers in the sense, this is one college, that is other college. We are all under one roof, that is Savitribai Phule University. Sir is a very renowned professor from CSPPU, recognized in the entire university.
तुम्ही कॉलेजमध्ये सोडा, तुम्ही मला भेटायला येऊ शकता.
So you can ask any questions. Yeah, please.
Sir, आपण जेव्हा प्रोजेक्ट करतो तेव्हा आपण फर्स्ट इयर बघतो की आपल्याला प्रोजेक्ट नॉवेल होणार आहे की नाही वगैरे. कारण की म्हणजे नॉवेल असलं तर आपल्याला बेनिफिट्स आणि आपल्याला जे काही नाव असेल तर बघितलं की ग्रीन सिंथेसिस किंवा
ग्रीन सिंथेसिस केलेलं नाही असं नाही. भरपूर काय बघितलं तुम्ही, कुठले ग्रीन सिंथेसिसचं बघितलं? कशाने बनवलं? ग्रीन सिंथेसिस म्हणजे काय म्हणतात? ग्रीन सिंथेसिसच्या भरपूर मेथड्स आहेत, म्हणजे अगदी मायक्रोवेव्ह सुद्धा ग्रीन मध्ये. ग्रीन म्हणजे काय? एन्व्हायरमेंटल फ्रेंडली. एनिथिंग विच इज एन्व्हायरमेंटल फ्रेंडली इज ग्रीन सिंथेसिस. कुठल्याही मेथड वापरू शकता. असं आहे तुम्ही अगदी ज्या मेथडमध्ये सॉल्व्हंट वापरून करताय तीच मेथड तुम्ही विदाउट ए सॉल्व्हंट तुम्ही ड्राय फ्युजनने जरी केली तरी ती ग्रीनमध्ये म्हणजे कंपॅरेटिव्हली ग्रीनमध्ये पडतो. असं आहे. त्यामुळं चॅलेंजेस काहीच नाही. तुम्ही फक्त वेगळं काय करताय का ते बघायचं. तर कसं आहे माहिती आहे का, एमफॉर्मचा प्रोजेक्ट आपण त्याच्यातलं काय बघतोय. माझ्या दृष्टीने एमफॉर्मचा प्रोजेक्ट हा फक्त शिकण्यासाठी आहे. तुम्ही जर म्हणत असाल मी एमफॉर्मच्या प्रोजेक्टमध्ये एखादं पेटंट करेन, आम्ही कमर्शियल प्रोडक्ट डेव्हलप करेन किंवा काय, ते तेवढ्याशा 6 महिन्या 1 वर्षाच्या काळात ते पॉसिबल होत नाही. फक्त ही सगळी प्रोसेस आहे. ह्याच्यात तुम्हाला रिसर्च मेथडॉलॉजी शिकणं एवढंच तुमचं ध्येय हे असू दे. पण प्रोजेक्ट असा निवडा की जर तुम्ही पुढे त्याला एक्सटेंड केलं तर काहीतरी देतं. तुम्हाला जर ह्या वर्षाच्या 2 वर्षाच्या काळात असं वाटत असेल की आपण काहीतरी कमर्शियल आउटकम निघू शकेल तर ते इतकं क्विक व्हायला थोडासा अवघड आहे. तेवढ्या वेळ नसतो आपण. पण असा प्रोजेक्ट निवडायचा की जर पुढे जाऊन तुम्ही रिसर्च मध्ये राहिला किंवा तुम्ही पुढे काय करा कुठल्याही फील्डमध्ये जा तर त्याला जर पुढे कंटिन्यू केलं तर काहीतरी करता येऊ शकतं. म्हणजे इथं फक्त तुम्ही आधी एमफॉर्मचं प्रोजेक्ट करिक्युलममध्ये डिझाईन करण्यामागचाच उद्देश आहे. रिसर्च काय असतो आणि कसा करावा हे शिकणं, ही प्रोसेस शिकणं एवढं जरी झालं ना प्रोजेक्टमध्ये तर ठीक.
Very good. What is your name? Please learn from her.
एक मुळात काय म्हणते का तुम्ही पहिलं बोलायला शिका. सगळ्या शिकण्याच्याच प्रोसेस आहे.
At least ask some questions. That is what we are doing. We are not expecting you to give the answers for the questions.
सुरुवातीला मी तेच म्हटलं की आपल्याला चुकीचं बोलायचं तर धरायचं पाहिजे. ते पण उदाहरण त्याचं काय वाटलं नाही पाहिजे. सगळे हसले तरी काय नाही वाटलं. कसं म्हणतो
रिव्ह्यू पेपर किंवा रिसर्च आर्टिकल बनवताना AI वापरावं की नाही?
म्हणजे आपण ते कशासाठी वापरतो हे म्हणतो. आपल्याला म्हणजे थोडा असिस्टन्स म्हणून वापरत असतो तर ठीक आहे. काही तुमचं रिपिटेटिव्ह वर्कला जर तुम्हाला सपोर्ट म्हणून वापरत असतो तर आपण काही डाऊनकी वर्क करा नको. पण तुम्ही तेवढं त्याच्यात ते जसं तसं तेच घेत असाल. आपण आपलं आय वापरतच नाही इंटेलिजन्स. दुसऱ्याच ते आय वापरतो काय करतो आपलं इंटेलिजन्स वापरतो. आर्टिफिशियल घ्या पण आपलं ओरिजिनल इंटेलिजन्स पण त्याच्यात जर वापरत असतो तर त्याला काय हरकत नसते. तसं नाही तुम्ही सपोर्ट घेऊ शकता पण तो स्वतःचा नॅचरल इंटेलिजन्स वापरायलाच लागतो. मग इथं काय होतं नॉर्मली AI मध्ये जसं तसं ते जे आहे ते तसं आपण त्याला काही बघत नाही. आता आम्ही वापरतो पण फक्त एक बॅकअप त्याला प्रॉम्प्टिंग पण म्हणतात. ते आपलं ओरिजिनल प्रॉम्प्टिंग पाहिजे. आपण प्रॉम्प्टिंगला काय द्यावं ते पण यायला विचारतो. दुसऱ्याला विचारतो दुसऱ्या याला प्रॉम्प्टिंग काय इथं प्रॉब्लेम. अदरवाईज टेक्नॉलॉजी कुठली वापरू नये असं मी म्हणतो. टेक्नॉलॉजी ती वापरायलाच पाहिजे पण कशासाठी वापरतोय ते म्हणतो. प्लीज हे चर्चा आहे आपली.
You can use AI for citation. Whatever the repeated citation which you like to make at the end of the paper, like arrangement of the reference. It takes a lot of time.
Oh yes. Mechanical.
Directly it will give you the sequence and the wonderful sequence. You can check computer based.
जाडा म्हणजे आपल्याला करायचं.
And the references each and every punchline, comma, you can give it to the AI, rearrange it and give it.
Right.
सर जर आपण 2 ड्रग्सचं मेथड डेव्हलपमेंट करतोय कॉम्बिनेशन करू बट सिंथेसिस नाही करू शकत कारण ते 2 API आहेत तर ते आपण बॅलन्स कसं करणार? तर सिंथेसिस एक आठवड्याचं
मेथड डेव्हलपमेंट हा वेगळा विषय आहे
हां
आणि सिंथेसिस हा वेगळा विषय आहे.
जर करायचं
दोन्ही पण
असं
करायचं.
म्हणायचं की academic म्हणजे असं project करू शकतो synthesis करून method.
पण तसं काही नाही. मग तिथं तुम्ही ड्रग कन्सिडर करू नका. तुम्ही 2 केमिकल सिंथेसाइज करा वेगळे. ते ड्रग असले नसं नाही आणि त्यांचं सायमल्टेनियस करा.
नाही बट मी ड्रग चूज केले.
ड्रग चूज केले असतील तर त्याचं सिंथेसिस तुम्ही ड्रगचं सिंथेसिस करून ऑलरेडी सिंथेसिस एस्टॅब्लिश आहे ना, तर ते नाही होणार.
ते कॉम्बिनेशन मध्ये मेथड डेव्हलपमेंट नाही झालं.
आणि तिचं म्हणजे फॉर्म्युलेशन करायचं त्या 2 ड्रगचं आणि नंतर मग ते method developmentसाठी जाऊ शकतो.
ते करू शकता. त्याला काय दोन ड्रग आहे, मग तुम्ही त्याचं फॉर्म्युलेशन करणार, त्या सिंथेसिस करणार, 2 वेगळ्या गोष्टी.
कर सकते हैं. There are functional groups which can react with each other. उसका hybridization
नाही त्यांना प्रो हे म्हणायचं म्युच्युअल ड्रग करायचं. म्युच्युअल ड्रग करू शकतो. म्युच्युअल ड्रग्स करू शकतात. 2 ड्रगचं एक कंपाऊंड बनवते म्युच्युअल ड्रग म्हणतात. दॅट इज म्युच्युअल ड्रग. म्युच्युअल ड्रग करताय मग आणि मग ते तुम्ही हायड्रोलाइज करा. 2 ड्रग फॉर्म होतील आणि त्यात एस्टॅब्लिश करायचं मेथड डेव्हलप. म्हणजे कसं एक ऍसिड आणि अल्कोहोल असेल ड्रग फॉर्म त्याचं एस्टर बनतो. तो म्युच्युअल ड्रग असतो आणि जो बॉडीमध्ये जातो तेव्हा हायड्रोलाइज एन्झाईममध्ये तो ब्रेक होतो आणि 2 ड्रग वेगळे होतात आणि त्यांचे मेकॅनिझम तुम्ही काम करता. तसे तुम्ही म्युच्युअल ड्रग्स करू शकता.
Okay. Any other? Shall we wind up? Sir, thank you very much, sir, for sparing your valuable time and almost 6 hours you spent at our college. Your precious time you spent with us, and we are so much grateful to you for the wonderful sessions which you have delivered in the morning as well as in the afternoon sessions. And the kind of response that you can see from the students itself shows that your presentation was commendable and excellent. And all faculty also, I told all faculty to listen to your presentation, leading from their practicals. And once again, on behalf of our management, we would like to extend a heartfelt thanks to you for presenting these students. Thank you.